In the previous video, we learned to plot a waveform on the stage of TuneScope. We can also use a pointer to tell where we are in the waveform. So the blue pointer is showing that we're about a half a second into the utterance. And then I've also got an end pointer, and that shows that the end of this utterance, that I believe that be the word one in the phrase 1, 2, 3, is about 9/10 of a second or so into the utterance. And I can play back the sound sample between those two points and determine whether that's correct.
1.
So, and I can guess that probably the next word is 2.
2.
So by using these cursors as pointers into the list of sound samples, I can not only graph the waveform, but I also can play back the sound samples associated with a given point in the graphed waveform. However, if I'd like to get a little more detail, I could plot every 10th sample instead of every 100th samples, and then I would get something that looked like this. So now I get a lot more detail, and I can use this detail to determine what the frequency of the utterance is. So, for example, each of these pulses represents the time between that the vocal folds opened and closed one time. So if I start here, I find out that the duration is about 0.012 seconds. And I can actually find then if I can determine if one sample lasts 0.012 seconds, I can find out the frequency, because that means that if I repeated that, it would have given me 83 openings and closings of the vocal folds in 1 second. So the frequency would be 83 movements of the vocal folds, back and forth movements of the vocal folds in a single second. So if I want a little bit more accuracy, I can look at more than one waveform. And so if I plot out 1, 2, 3, 4, 5, the duration for 5 cycles is 0.053 seconds. So if I plot 0.053 and then divide that into 5, then I find that I get a frequency of about 94 cycles per second. So there's a little bit of variation from waveform to waveform, but if you average it out, it's about a frequency of 94 cycles per second. And since I have this variable that I'm displaying called duration, I can, if I want, just drop the duration in between the two pointers, and essentially that saves me a step. So for example, if I took another 6, 7, 8, 9, 10, if I get 10 samples in about a 10th of a second, obviously I could get approximately 100 cycles in 1 full second. So by this means, we can we can use the plot of the waveform to determine how many times that the event of the moving of the back and forth of the vocal folds occurred in a full second, and that is essentially the frequency, the fundamental frequency of the sound. And once I have the fundamental frequency of the sound, I simply can determine what musical note is associated with that frequency in a case where the display represents a song or vocalizations by a singer.